We haven't even started drawing the orthographic views yet, and your TA Serenity is already exhausted just looking at it. And for good reason. This is probably the hardest orthographic projection problem that I would give to a student early on in the engineering graphics course. Drawing circles and cylinders alone is already pretty tough, but once you add cutouts so you get a bunch of circular arcs, that just kind of increases the level of difficulty right up to about your limit. But we plow through, just like always, starting off by drawing a bounding box. This is actually pretty tricky to draw for a cylinder because it's sort of hard to see exactly where some of these back corners are. But with a little bit of trial and error and a couple of corrections, I get to a glass box that completely encloses my shape that is a length of 6, a height of 4, and a depth into the page also of 4. But if I were to draw my drawing on my graph paper at those dimensions, it would actually be way too small. For the size of my graph paper, I actually need to multiply all of these numbers by 2 in order to make the drawing large enough to generally fit my space. And that's how you're going to decide how to scale your drawings. You're going to look at what dimensions are in the drawing you're given, and then how big the squares are in your graph paper, and multiply or divide the dimensions you're given in order to fit the size and space of your available paper. So I'm drawing my bounding box with dimensions 8 by 8 by 12. And I'll just have to remember every time I measure something on the isometric drawing, I need to multiply by 2 before I put it on my front view, top view, and right side views. So a cylinder is going to look like a circle from one view, in this case the front view, and it'll just look like a regular rectangle when looked at, in this case from the right or from the top. It's almost always easiest to draw cylinders. Sorry, your TA Serenity's being kind of cute when she turns upside down like that. It's almost always easiest to draw cylinders with the circle first so that you know where the quadrants are, right? The north, south, east, and west points of the circle, because those are going to be the extreme top and bottom of your rectangle and the left and right side of the rectangle on the other views. So for this problem, I'm starting with the front view circles first. So the large circle goes from bottom to top. It's the full size of the drawing with the left edge of the circle all the way at that sort of back left edge of the drawing. And on the isometric view, the small circle, right, the inner hole that goes all the way through, it is 2 squares in diameter on the small drawing, which will make it a 4 square diameter on my drawing. It's not a finish, the flat face, it's actually touching the front of the drawing. I'm drawing these vertical lines. On the isometric view, those look like they're about 1/4 of the way in each square, so I'm drawing them as 1/2 of a square on my drawing. And this is kind of an estimate. If I really wanted this drawing to be perfect, I would probably want some actual numbers on the isometric view, but just eyeballing it, this is probably about as close as I can get. So I'm working from front to back, and so the next thing I'm going to see is the flat surface that kind of corresponds at the bottom of the drawing, like that bigger square. And it goes all the way from the right-hand side up until it hits the larger cylinder. Another rectangular face right above it for that smaller square area. It's all the way at the right side and all the way at the top, and it goes also until it hits the big cylinder. There's nothing that would be hidden from the front that's blocked by anything, so no hidden lines on this view. So to finish up, we just do the center line right through the center of the circle. Center lines are a long, short, long, so I start these off by just drawing a small plus in the center of the hole, and then extend outwards, up, down, left, and right, a longer dashed line. And in this case, I had to do something a little bit strange. Over on the right side, if I drew the center line all the way through the outer circle, it would overlap an existing visible line, which you're not allowed to do. Visible lines have priority over center lines, so I had to call an audible and adjust it a little bit. The center line still crosses over the smaller circular hole, but it doesn't go all the way to the outer circle so that it won't overlap that visible line. Moving on to the top view, we're going to start all the way at the top and work our way down. So the flat surface on the top that corresponds to that small square section, I'm going to draw that one first. And it will go all the way to the top of the cylinder, so it lines up directly with the top of the circle on the front view. But what I'm not going to do, and this is something that doesn't exactly match the isometric view, I'm not going to complete this rectangle and draw that vertical line that should go directly at the top of the cylinder. And I'm not going to draw it there because that's not actually a corner. There's a very smooth transition from this flat surface to the rounded part of the cylinder. And this is something you'll see drawn differently in different places. Some people like to draw the edge here and some don't. It's my preference to not include it because it's not an edge or a corner. So even though it's drawn on the isometric view, I'm not going to draw it on my view, but either option would be correct. If you wanted to draw it there, it's not wrong, it's just kind of different. Ultimately, your goal is to be clear, to make sure that your drawing is going to be understood by whoever is viewing it. And this is one of those cases where the person viewing the drawing can probably figure out what's going on either way, if the line is there or not. So working from the top down, next visible surface is going to be the rounded surface of the cylinder itself. TA was looking at me with those eyes like she wanted some scratches, so real short little scratch break for your TA Serenity. She's being a real sport, helping us out. So from the top view, the rounded surface of the cylinder looks mostly like a rectangle. But the very bottom of the top view is going to be kind of open. There's a little bit of a cutout there. That's where there's sort of a vertical rectangular hole from the top down to the bottom right at the front edge that's missing. It's removed, cut out. So I finished this rounded face by drawing this notch, 2 squares set up on my top view. And I find the left and right boundaries of this notch by lining it up directly above the front view. And that's exactly why you draw the top view exactly above the front view, because features should line up right on top of each other. Next surface down is going to be at that square on the right-hand side that's a little bit fatter. You can see part of it is going to be hidden beneath the surface we already drew, but part of it will still be visible. Now, the parts that are directly beneath the visible lines don't get drawn because visible lines have priority over hidden lines, but there is one small little section here that's not covered up by anything else where I will draw a hidden line. And normally hidden lines start with the dash, but since this little section would be continuing visible lines that are already drawn, I'm actually starting them with the gap to make it very clear exactly where the visible lines end and that this entire middle section is hidden. So that's going to be all of the visible faces that are visible from the top, but there are some more hidden features we still need to add. In particular, there's the round hole that goes all the way through the middle of the part, which will go from the front to back, which on the top view means from bottom all the way to top. So this is going to be 4 squares wide, lining up directly above the left and rightmost points of the circular hole on the front view. And next, the 2 lines that almost everybody would forget when drawing this for the first time is on the underside of the curved cylinder where these side square surfaces intersect and are tucked underneath the cylinder. You will be able to see those vertical edges underneath the cylinder. So for the largest square, this is going to be a continuation where it goes from right to left. We already drew this as a visible line, but it's going to continue underneath the cylinder as a hidden line. And then for the smaller upper square that's near the top of the cylinder, we're going to have on the top view, it will be drawn as a vertical line, but over on the isometric view is where the bottom edge of this rectangular shape aligns alongside the edge of the cylinder. And these 2 little tiny hidden lines have to be the #1 thing that most students would be most likely to miss on this drawing. So last step, draw the center line right through the center of the cylinder, and we're 2/3 of the way done. Your TA Serenity is fallen asleep. She's completely abandoned us. We're on our own. What are we gonna do? Just move on to the right-hand view. Let's try our best, and if we really struggle, we can wake her up to help us out. Let's see if we can get it done without her help. Right-hand view, we draw from right to left. So you start off with the square faces that are touching the rightmost surface. We've got a large one on the bottom and then a small one up at the top. Next will be this blue outline, right? The curved surface of the cylinder itself. That will also be visible from the right. Over on the right-hand side of the right view, which is like the back of the part, it's going to be the full height of the cylinder. But on the left side of the right view, which is the front of the part, remember that it actually is a little bit shorter because there's that notch cut out from the top and the bottom. So we have to line up from these points near the top and bottom of the front view and line them up. And that's actually the maximum height on the right side view at this section. So this is another part that would be commonly missed by students just starting off in engineering graphics. This takes a little bit of experience before you start recognizing to check for these things. So that's the end of the visible portions, but there are some hidden surfaces. So the first hidden surface that I'll draw will be these 2 blue squares, which are part of that sort of front notch sort of section. We know from the top view that the notch is set in 2 squares, so it's going to be set inwards 2 squares on the right view also. And the height we can find by tracing from the front view, just tracing left to right from the front view. You can see how tall these rectangular faces are. The height of these rectangles are found by tracing horizontally across from the front view. And the height of each of these blue rectangles we can find from the top view by tracing a line across the miter line. So on the top view, the notch is set in 2 squares tall, so we reflect that across the miter line to see that on the right view, it'll also be set in 2 squares of depth. And the last hidden surface is going to be the small hole itself that goes all the way through the part. And since we've got the circle drawn on the front view, the very top and bottom of that circle, we can trace those heights over to the right-hand view, and that gives us the location for the hidden line that goes all the way to the back of the part. But remembering, it doesn't start at the front of the part, it starts at the notch, right? The top and bottom points don't start at the very left or front surface, right? The notch sets it inward, so the top and bottom of the circle don't start until kind of 2 squares in. So if you were able to follow along, even though your TA Serenity was sound asleep that whole time for the right-hand view, I'm really impressed. Thanks for sticking with it. That's really, really awesome. But if this was a bit much and you want maybe a little bit of a smaller problem, a little bit easier practice, then watch this next video that's linked on the screen now. It's still about drawing cylinders, but maybe it's a little bit easier for beginners, or even if you're getting pretty good at this, it's still just good quick practice.